Hey students, Professor Newton here. In the last video, we discussed how one way to, or the most effective way to overcome omitted variable bias is to use a regression in which the omitted variable is no longer omitted. We include the omitted variable as an additional regressor in multiple regression. In this video, we are going to introduce the population multiple regression model. We will consider the case of two regressors, and the case of two regressors extends very nicely to multiple regressors. So for the case of two regressors, our population multiple regression model is this equation. Let's call this equation 1, where yi is equal to beta naught plus beta 1 times x1i plus beta 2 times x2i plus ui for I equals 1 through n, where y is the dependent variable, x1 and x2 are the two independent variables. These are the regressors. Collectively, yi, x1i, and x2i denote the ith observation on I, x1, and x2. What this means is that collectively this would be the set of, or the observation of the student to teacher ratio, the test score, and the percent of English learners for the ith district. Okay, so this is the observation for each district. You have a variable measured, observed for each district. Beta naught is the unknown population intercept. Beta 1 is the effect of y, effect on y of a change in x1 holding x2 constant. Typically we think of the change in x1 being a 1 unit change. Beta 2 is the effect of the effect on y of a change in x2 holding x1 constant. And ui is our regression error. These are the omitted factors. We're going to talk about using ordinary least squares to estimate these unknown population coefficients in the next video. In this video, we want to focus on the interpretation of these coefficients in multiple regression. So we still have this is equation 1, where yi is equal to beta naught plus beta 1 times x1i plus beta 2 times x2i plus ui for I equals 1 through n. And we're going to think about the interpretation of the coefficient beta 1. Alright, so we're going to think about how to interpret that one. Consider the difference in the expected value of y for two different values of x1 holding x2 constant. We're going to use some math for this so that we can demonstrate what we mean. So the population regression line, when our variable x1 is equal to x1, 0, so x1, 0, what we mean by this is x1 at the initial value 0. So this is y equals beta naught plus beta 1 times the initial value of x1 plus beta 2 times x2. Then, when the population regression line, when x1 is equal to that initial value of x1 plus a change in the value of x1, can be expressed by using this equation. We have y plus the change in y is equal to beta naught plus beta 1 times the initial value of x plus the change in x1 plus beta 2 times x2. Notice that we have kept x2 constant, so we are looking at the change in y. Let's make that an arrow. That's the change in y that will be caused by the change in x1. Whoa. All right. So before, we had y is equal to beta naught plus beta 1 times x1 naught plus beta 2 times x2. And after, we had y plus delta y is equal to beta naught plus beta 1 times, in parentheses, the initial value of x1 plus the change in x1, close parentheses, plus beta 2 times x2. x2 is being held constant. Now, we can take the difference of after minus before. That's what the difference is. After minus before. And what do we get? On the left-hand side, we are left with delta y, the change in y. On the right-hand side, we're left with beta 1 times delta x1. Now we can divide both sides by delta x1, and we get an expression, an interpretation for beta 1. Beta 1 reflects a ratio, okay? It is the change in y given a change in x1 holding x2 constant. And typically, we think about a change in x1 being equal to 1, right? So beta 1, we think about beta 1 telling us how much the outcome variable changes for a 1 unit change in x. And so this is the very same interpretation as with univariate regression. The difference here is that this interpretation requires the condition that we are holding x2 and all of the other variables constant. And the same interpretation goes for beta 2. Beta 2 is the change in y given a change in x2 holding x1 constant. The value of the intercept, this is analogous to univariate regression. The value of the intercept is the predicted value of the outcome variable when both of our independent regressors are equal to 0. And sometimes, most of the time, this won't have any economic interpretation. This just tells us the intercept, where our line is going to best fit the data. Okay, and so this is the population multiple regression model.